Hi, this is Sudarshan. I'm a master's student at the University of Florida, and this is going to be a short demo on a project that I did for my image processing class here at the University of Florida. So my project was on image stitching, and what I did was I developed a small application using MATLAB that could bring together two pieces of the same image together and stitch them together to form one single image. And um, so I'm pretty sure all of us have seen image stitching done before. Most of us must have apps that um, like brings together lots of images to produce these pretty panoramas. So this project is actually a very simple image stitching application where two pieces of an image are put together, and there's scope for improvement. There are many robust algorithms out there that can produce much better results, but this is a good starting point. Okay, so what is image stitching? As I mentioned before, it's just the process of bringing together images to form one big image, where the completed image is complete in every sense. It has good fidelity, it looks good, it's pretty, and this has been around for a very long time. So since the early 90s, photographers used to take these photographs and put them together and to form huge panoramas that looked really good. And in the recent past, this application has become mobile, so I'm pretty sure most of us have like mobile phone apps on our Android or iOS devices that can do this process for us. Okay, so how do we go about doing image stitching? So there are basically 4 steps. The first one is a motion modeling. So what is a motion modeling? So let's say I have two pieces of the image. So I need to bring them together. So I need to write a motion equation for one of the images to bring it closer to the other image, right? So that is the motion modeling part of the whole process. And once the images have been brought together, you need to find a way to put them together so that they align to produce one coherent image, and that is the alignment part. Then we choose a composite surface, like the two different images could be of different shapes and sizes, but the final image output should be one big canvas. And in the end, we do post-processing where we try to hide the lines that, or the blended lines that form at the boundaries and the seams. Okay, so this is a little bit of behind the scene math that happens. So this is basically an affine transform. That the affine transform is basically does the motion modeling part that I talked about. So what is an affine transform? It's a mathematical transform where parallelism is preserved across the transform. So parallel lines tend to stay parallel, and midpoints tend to stay midpoint, and it is perspective independent. So when you do an affine transform, circles do not get warped into ovals and such. So basically it is totally lacking in any kind of perspective projection. So the 4 basic steps that an affine transform can do are rotation, translation, shear, and scaling. So this is basically a simple affine transform where these points are scaled and then translated. And this is a 6-parameter affine transform matrix where A1 through A6 are the parameters that are returned, describe the motion equation, and these are the the location points that we need to feed to the matrix so that it can figure out how to move one image with respect to the other. Okay, at this point I'd like to give you a short demo of my project. So this has been done entirely in MATLAB using MATLAB's inbuilt functions and toolsets. So I go ahead and type IP project. In fact, I think I have it running in the background. So yeah. So this is the starting point where this is called the control point selection tool, where the user manually selects 3 points of correspondence between two pieces of the same image that I have here. As you can see, this is a pretty long train that has been cut into half with a bit of overlap so that the user can go ahead and identify the points of correspondence between two images. So the white speck here should be a good starting point. The windows here and the top of the train, I've gone ahead and I've selected 3 points already, and I've exported these points to the workspace. And once that's done, this is the transform that MATLAB deemed ideal for bringing the two images together. So this is one piece of the image, and this is the other piece, and this is the image that is joined together. As you can see, it has done a pretty good job of recreating the original image. From what I told you, you would have noticed that this is a pretty manual process. Ideally, you would want a least squares algorithm to operate in the two boundaries so that the algorithm is more robust. Basically, there are a number of different very robust algorithms that can do the job for you, but unfortunately I haven't implemented a very recent algorithm for this project. Okay, so the next part of the project is the canvas placement, where okay, so once the images have been brought together, you need to figure out how big the final canvas needs to be so that the both images fit onto the canvas as one single piece, and that can be figured out based on how one image is moved with respect to the other and the sizes of the two images. As you can see from this figure, let's say I move the red image from here to here, so I would place my canvas to encompass both these images. So I would fix this as 1 point and 1 point, just to give you a general idea. So this is the kind of thinking that needs to go into the coding, and I've done that. So that's basically it. Thank you.